Welcome, everyone. There are quite a few seats up front. If you want, you can step up here. I won't ask you any questions, I promise. I won't call you out. We are here to talk about tank and line integrity testing. And first thing we're going to debunk about it is, what the heck do you really call this stuff? You know, there's been, for about 25 years, people use different names for it. In the state of California, it's called the integrity test. EPA has called it the tightness test. Some people still call it a precision test. I may slip back and forth between those three of those. If I do, I apologize. We kind of call it anything. If you call us and want us to test your tank, we will go test it for you. I'm going to give a brief overview of the regulatory requirements. If you just stepped in here, don't think this is all you need to know about regulations. This is just very brief. I'm going to talk a little bit about our tank testing history with technology, then go into some of the specific types of tests, including the technology methods, the Sure test and the Evacute and the TLD1 line test method. So, formal tank tightness testing or integrity testing started with the EPA back in 1988, which coincidentally was the year I started in the business with Exxon. I see a number of familiar faces out there, that folks who've got at least that many years of experience. So to some of you guys, none of this will be new to you. But the EPA came up with a definition of a tightness test, which was a way to say, what size leak do we want to really be able to find in these tanks? They came up with 1/10 of a gallon per hour, which was what they considered kind of the best available technology, or kind of the smallest leak that could reasonably be discovered in a tank. You know, it had to account for the effects that would impact that tank, things like the thermal expansion and contraction of the product, things like vapor pockets and tank deflection, and things like evaporation and condensation, and also the water that may exist in the soil down around the tank. They came up with a requirement that the methods had to be certified by an independent agency to verify that they could find 95% of the leaks that existed and have a false alarm rate of less than 5%. The regulations required a phase-in period for leak detection. This was a huge task to undergo across the United States. You know, there were many, many thousands of tanks, possibly in the million tank range. And tank tightness testing was a very common choice of the owners, combined with inventory control. It was such a burden on the industry that there was a phase-in period to allow for the ages of the tanks and then the dates that they needed to be tested. You know, if the tank was installed in 1989, or it had to be tested by 1989 if it was installed in 1965 or sooner, or an unknown date, which was pretty common back then, that there were tanks in the ground and nobody knew how long they'd been installed. And as you can see, there were phase-in periods. So this was, in some ways, kind of the golden age of tank testing. There were tank owners all across the country scrambling to get a tank tightness test completed. This lasted pretty much until 1998, at which point, tanks had to be upgraded with some sort of continuous monitoring system, and there were various requirements in California as well that may have superseded this date. But once a tank has an approved monitoring system installed, then the annual tank and line tightness test may no longer be required. The California regulations, there's two areas that one defines what a tank integrity test is. This is very similar to the tank tightness test requirement, references 1/10 of a gallon per hour, references a third-party certification, references the requirement to account for all of the factors in the ground and in the tank. There's one stipulation in California that the tank must be 65% full, which was kind of a unique local requirement. And in California, there is a state licensing requirement. Those of you who know Sean probably know quite a bit about that program. So there is a list of the technicians who've gone through the training and certification program who are licensed and legal to conduct a tightness test or an integrity test in California. So the reasons for tightness testing, you might think, well, if there's not an annual regulatory requirement anymore, why do you test? And there are some exceptions. I'm not going to try to go into all of them, but there are some nuances where there may be a periodic regulatory requirement. But from our experience with technology, that's a very small percentage of what we do in the state of California today. The main reason we test is for a transfer of properties. As you probably have known and observed in your areas, the major oil companies are divesting their stores at a very rapid rate. And they usually like to have one final certificate to say, this site was tight, everything's in functional working order, everything's good to go. That's been the biggest driver for us. There are other reasons as well. If one of the other methods of leak detection indicates a possible problem, something like the SIR or ATGs, and some of this applies more in other parts of the country, but if any of those indicate a suspected leak, then tank and line integrity testing is still a viable option to determine if that is a leak or not. And then in a lot of areas, there's still the need for testing for new construction verification. I'm going to give a brief overview of the types of tests that were attempted on tanks. This is going back before my experience, before I was born, in fact. I heard stories about testing in the 60s using an air compressor, just hooking a hose up and putting pressure on that thing, see if it'll hold. These are stories that some contractors told me in the late 80s when I was working with them. They said, well, that's the way we used to do it. So every now and then you'd pop an end out of a tank, but that tank wasn't good anyway, or something like that. But the NFPA came up with some, wouldn't really call them standards, but they referenced something called a standpipe test as early as 1964. That's the earliest I could find anyway. And they realized that it was not a very valid precision test. It had a lot of shortcomings. It was somewhat dangerous. There's product up above grade. There were no real standards. They weren't able to account for the thermal expansion and contraction of the product and for the end deflection that occurred. Moving into the 70s, there were some methods that started to account for some of those things. I'll let Steve tell a little bit more about that with the petrotite method that his father developed. It started to accommodate, to do a temperature measurement, and to do a more accurate measurement of the level to try to get an actual calculated, quantifiable leak rate. There were still some limitations of that method as well, including one that my former company, NDE, had created, which was an overfill test. We had tried as well. We threw some temperature sensors down in the tank. We had a pump to circulate the fluid and try to get the temperature to stabilize a little more quickly, but it still had some of the drawbacks of possible air pockets and end deflection and deflection of the tank. During the 1990s, which again was somewhat of the heyday of tank testing, a lot of technologies were flooding onto the market to meet this increased demand for the annual or the periodic testing. And most of these fell under what we call underfill tank testing. That was where you could come to a site and test at whatever the typical product level was. And it also used more of a modern technology, started to use computers and electronic data acquisition systems to eliminate some of the manual data keeping that the technician would have to do. So there were some advantages with precision for these new types of tests, a little bit with safety. There was not as much fuel to be handled above grade. There was certainly convenience for the tank owners who were the ultimate customer and paying for these tests, where they didn't have to get deliveries in, and it was a little bit less shutdown period for them. The technology experience started way back at the beginning. If you look closely, you can see the gasoline was a little bit cheaper back then. Wish it was still under $1 a gallon. Then over the years, we calculated that we had tested in the range of 1 million tanks. That was back, I think that was about 2006 we had calculated. The rate of our testing tanks has dropped off quite a bit since then, but we have quite a bit of experience. Our computer database of our leak test results only went back through 1996. I put this chart together for a presentation I did about a year ago. During 1996 and 97, and then into 98, we were doing kind of the final run of some of these annual periodic tests on tanks. So there was a pretty good failure rate. This is listed as passing rate. In some cases, only 75 or 80% of the tanks were able to pass the test. Now, a lot of those tanks, they failed that one last time. They were taken out of business, and the sites were closed down. In the years since then, a lot of the testing has been done for reasons like property transfers, things like that, and the passing rate is much, much higher. And then also, one thing to note, these are not failures with a hole in the tank and fuel leaking out. Some of these could be tank top issues with the associated vent and other piping attached to them. The types of tank test methods can be split into two main categories. One is considered a volumetric tank test method. This is where the system tries to calculate whether fuel is coming into the tank or going out of the tank, or any liquid. It calculates an actual leakage rate and then compares that to the threshold to say, okay, do I have a leak or not? There's many examples like Alert, Mass Tech, Sure Test, VPLT, and US Test, which you probably won't see much anymore. The non-volumetric was a different category, which said, hey, there are other technologies that exist that may not quantify a leak rate, but they can give a yes-no answer to determine if a tank is leaking. Those use technologies like acoustic or possibly ultrasonic listening. It could be a vacuum or a pressure decay test or a tracer gas technology. And there are many examples of those types of tests as well. I'll give just a brief theory of the volumetric tank testing. This is what I call kind of the classical volumetric test, where you measure level and temperature. Steve, I believe, is going to talk about the alert testing, which gives a quantitative result in a different way. But the volumetric test applies to our Sure Test method and a number of other methods that try to measure the level of the fuel and then the temperature of the fuel and then calculate a leak rate. It's fairly simple in a way, but there's a lot of math and algorithms into it. The float or another sensor just measures the change in height of the fluid during the test period. And then with the data that's entered into the computer, it calculates kind of the length and width of that cross-sectional area of the tank, and calculates the volume change. And this is what I call the actual volume change that's occurring in that tank. Now, in order to get a precision test, you have to compare that to what's happening with the fuel. It could either be expanding or contracting, and I can almost guarantee it will be doing something. Even in the most stable tank, there's enough temperature change to cause quite a bit of expansion or contraction. So most methods account for the fact that the fuel tends to stratify. So there's an array of temperature sensors that are placed vertically within the tank, and then each one of those measures the temperature change during the test period, and then it calculates based on the volume that is associated with that what the thermal expansion or contraction would be. So then to come up with the final leak rate, you would take the difference between those two. Say, what was my actual measured leak rate compared to what was the thermal expansion and contraction to see what it should have been. And then if that is above the threshold, you would declare that tank to be leaking. This gets into a little bit of the statistics, the probability of detection and probability of false alarm. This may be easier to understand if you consider it being for a volumetric tank test. If you look at the line under the blue, that might represent a bell curve. If you went out and did 100 tests on a tank that was not leaking, it was perfectly tight, because you're measuring all these numbers, you're not going to get exactly 0 every time you measure the leak rate. Sometimes it's going to be a little bit less, sometimes it's going to be a little bit more. It'll give you somewhat of a bell curve representation. On the other hand, if you tested 100 tanks that had an exact 0.1 gallon per hour leak rate, you're going to get a similar bell curve with the distribution. So the false alarms had to mean that when you're testing a tank without a leak, this bell curve, which is represented by blue, the line that goes past the threshold right around here, the number of tanks that gave you a leak result higher than 0.05 gallon per hour had to be less than 5% of the tanks you tested. And then on the tanks that were leaking, this other bell curve that's going to give a quantitative leak rate of 0.08 gallon per hour, 0.12, or 0.1, something like that. You had to have 95% of them that gave you an answer that was over the threshold of 0.05. The Sure Test methodology is a technology test that fits in this volumetric category. It's a magnetostrictive level sensor, which is the same technology used in a number of automatic tank gauge probes. It has integrated circuit temperature sensors, and it actually runs on a 9-volt battery. It is an underfill test method. It tests at the existing product level in the tank. The data is collected by the probe and then transferred into a laptop computer to actually run the calculation of the leak rate. This is kind of a depiction of it. The probe is inserted vertically into the tank. The The float rides up and down on this magnetostrictive rod and rests on the fluid level, and then temperature array hangs down into the product level to measure the temperature at various points. When the data is collected and analyzed in the computer, it graphs out over time the level and the temperature graph. And if you get something like this where they're both parallel, then that's indicative of a tight tank, and it would give a passing test result. A leaking tank would give a different result. You may have a temperature change that's decreasing slightly, but then a level change that's decreasing even more when it's multiplied to represent the total volume change. So when you have diverging graphs, that would represent either a leak or perhaps an ingress into the tank if there was a high water table or other water condition that was draining into the tank. Because it's an underfill test method, it would have to be followed up with an ullage test. The one we use is called the U3 ullage test. It's a non-volumetric and acoustic-based test. It can be used either with a vacuum or with pressure to detect any leaks in the ullage or the non-wetted portion of the tank. The California, in addition to licensing the tank testers, they have their own list of the certifications of the methods. So on this kind of famous LG 113 list, it lists all of the methods that have gone through a third-party certification and kind of the different operating parameters. I couldn't fit it all on one slide, so I summarized those a bit. It lists, for the sure test, the probability of detection is very good. It's near 100% during the certification test and near 0% for the false alarms. We do use the 0.05 gallon per hour threshold, which is very common. It's applicable to a number of fuels as well as other liquids with a known coefficient of thermal expansion. This is what's very important for this traditional type of volumetric test. If you don't know the thermal coefficient of expansion, you can't really do a test on it. So there are many fuels that the coefficient of thermal expansion can be calculated accurately and can be tested, and many other chemicals as well. There is a waiting time required before conducting a test after a delivery, and that's been established as 6 hours. Normally when the delivery comes into the tank, it will stir up the product. You'll have a period of time where there's pretty rapid rate of thermal expansion or contraction. There can be a little deflection on the tank, even if it's just a delivery that's below the overfill limit of the tank. The maximum tank size is 18,000 gallons. I don't know that I've ever seen an 18,000 gallon tank. That's based on a rule that was included with the certification process, where you could multiply the actual tank that you certified on by 1.5. So we had certified this method on a 12,000 gallon tank. And then the product level had kind of similar kind of arbitrary numbers that we had done testing between 11% and 95% full. The technology and the sensors actually work at any level within the tank, but that's the certification results. It does require a minimum of 3 hours of data collection. As you can see in this picture, this method is commonly used at night because it runs on a battery. The probe can be inserted into a tank and then just gather data all night long if the station is shut down. The groundwater must be measured in order to ensure that there is enough pressure differential to cause a flow if there were a hole in a tank. It could be possible if there's a hole in a tank and the hydrostatic pressure inside the tank is equal to the hydrostatic pressure of the water outside the tank. So that's why it's important to measure the groundwater table around the tank to verify that there's enough pressure differential, which California has stipulated must be 1 psi for the pressure differential. I've come up with a comparison. There's a lot of similarities between the sure test methodology and a typical magnetostrictive ATG probe. They're both a volumetric type test. You use a similar sensor. ATG magnetostrictive probe is typically much longer, goes the entire vertical diameter of the tank. The sure test is certified at a 0.1 gallon per hour. Most ATG probes have gone through certification at a 0.2 gallon per hour. With a sure test, you have to have a certified technician on site to deploy the test. Most ATG consoles run automatically, or they can be initiated from the console, or perhaps even remotely, which could be a benefit. The sure test, or an on-site tank test, typically requires some isolation of the tank, so it can rule out any other piping. If there is a leak that may be identified, to rule out any ancillary piping, the technician can isolate if necessary, whereas an automatic tank gauge probe is going to test whatever is there at the time. If there's a spill bucket that's got some water that's dripping down into the tank, that's just going to be part of the test that day. The coefficient of thermal expansion is very important. With a tank integrity test, the technician will actually measure the fuel and test the fuel at the time he's conducting the test to make sure he gets the proper coefficient. The automatic tank gauge probe is going to rely on the programming of the console. There is a feature on our Sure test to eliminate stiction, or the static friction that may occur on any moving part. If there's not much movement, there could be a little bit of friction. We have a shaker mechanism to help eliminate any of the stiction that may occur. I'm not aware of any ATG probes that use that feature. They do have typically a larger diameter float, which may offset that somewhat. With the Sure test, you saw an example of the graphs. The trained and certified technician will evaluate those for the best and the most stable portion of that graph. Usually the first couple of hours of any test, there's some equalization that's occurring, and it may take a while until it stabilizes enough. The ATGs use a proprietary algorithm to calculate a leak rate. A tank integrity test is kind of a real-time snapshot of the condition of the tank, as compared to some automatic tank gauge systems may be running continuous leak detection, where they could have data that's been collected over a long period of time, maybe a month or so. So it may not be indicative if a leak had just started to occur that day. And then with the tank integrity test done in the underfill mode, it's usually followed up by an ullage test that would check for any leaks that are occurring in the non-wetted portion of the tank. Our non-volumetric test method we use is called the Evacute method. It tests the entire tank and piping all as one. So even though it's done with the fuel at an existing level in the tank, it also includes a test of the ullage. So there's no separate test required. It is, as far as I know, the original vacuum acoustic-based test method, and there were several patents for this technology. Here's a brief overview of the test. A probe is inserted through a riser into the tank, and there are the openings to the tank are sealed, such as the vent line and any other piping, and then a partial vacuum is applied to the tank. If any air is drawn into the tank from the soil, it would bubble up through the fuel, and that would be detected by the acoustic sensor in the probe. If any hole at the top part of the tank existed, and it would draw air in, and it would cause an acoustic sound as well as a loss of vacuum in the top portion of the tank. And then if the tank happened to be buried or submerged in water, and there was a hole and water was drawn into the tank, there's a water sensor that would measure the increase of water at the bottom of the tank. So with the setup of the Evacute program, it requires a technician on site, certified technician again. He has to take apart all the fittings on this tank and really identify the conditions of this tank and do almost a site survey before he even starts the test. Because he takes that data and enters it into the computer. The computer runs the vacuum pump. And there's a very fairly complicated algorithm to make sure that enough vacuum is applied to ensure that if there is a hole there, that any air or water will be drawn in. It's also careful to make sure that the vacuum is not so much that it could damage the tank. So after that is done, the technician connects his probes, connects the vacuum hose. The probes themselves have these sensors built in. There are some other methods that may have separate sensors, and sometimes I get questions about that. Did you use the water sensor on that test? Like, we don't have a choice. It's part of the probe. The water sensor, the transducer, and the hydrophone, as well as a thermistor, are all part of all of the probes. We do have different technologies that use slightly different water sensors, and I'll cover that in a second. Another note I'd like to point out is that these probes are essentially calibrated at the beginning of every test. They are zeroed out to atmospheric pressure, and then as they are inserted into the tank, because of the measurements of the amount of fuel and the liquid height of the fuel, that's all entered into the computer. Then the pressure transducer on the probe will measure the amount of pressure as the probe is immersed into the liquid, and those have to match up within the tolerances, in essence, to calibrate the probe at the beginning of every test. So all of the audio signals from the probe are digitally recorded, and all of the data from all of the sensors is recorded throughout the test. The connections to the tank can be just about anywhere. There's a lot of different tanks, and over the years we've come up with a lot of different ways you can hook onto a tank. We've got cones and bladders and stingers and all sorts of different things. So this kind of up here at the right, this is the typical or traditional way that you may have seen photographs, where you just run a hose up to the top of the vent stack and pull your vacuum from there. But that is actually not the most common way of doing it now. We use a lot of these fittings that are a kind of a coaxial fitting, where you can have a probe cable running down through the middle, and then the vacuum hose comes into a T on the side. So that's something, if you're at a site, you may not be aware. The technician may just run up to the top and put a simple cap on the vent. Here's a different type of fitting that you can't even see. There's a cone that's down there where the probe is going into the tank. And that one actually is an inflatable bladder, I'm sorry. This is a different fitting where it's a stinger that goes down to the extractor T, where a ball float would be installed in a tank, so we can pull a vacuum through there as well. Here's kind of a graphical representation of the different ways that we could detect a hole in a tank. If there's a hole in a tank that's just buried in fill without any water around it, it will draw in an air bubble, and that will cause an acoustic signature that's a very readily discernible acoustic signal. If there's a hole in a tank above the product level, it will cause a different type of an audible sound into the tank, and it tends to cause a loss in vacuum as well. Although that's not part of our third-party certification, that's something that our software accounts for. We monitor very closely this decay in vacuum that occurs if there is a hole in a tank. And then if there's a hole in a tank that's buried in the water table that draws in water, that water will accumulate at the bottom of the tank. And again, the integral water sensor will measure the increase of water. Just like the Sure test, we have a listing with the LG 113 that lists the operating parameters for the test. The leak threshold, you notice, is not a quantitative number. That's why it's non-volumetric. We can declare a tank to be not passing if it's got an air ingress in the ullage area, or if it's got a bubble ingress through the product area, or if there's a water ingress. And at times, we also have identified leaks through this vacuum decay and the pump cycle analysis. The method is applicable to a number of types of fuel and other products that are not miscible with water. And I didn't write it on here, but the products also have to be less dense than water. So basically, water has to be able to enter into a tank and then settle to the bottom of whatever fuel is in that tank. Now, that would not apply if it's been determined that there is no water table around the tank. If that's measured through a well point or something, so it's known that the water table is below the tank, or for instance with a double wall dry interstitial tank that would have no chance of water ingress. And because it's not volumetric, there's no waiting time between delivery and testing of the tank. It was certified on a 50,000 gallon tank, so the certification is valid for tanks up to 75,000 gallons. There's a maximum of 30,000 gallons per tank, or 60,000 gallons total if you have manifolded tanks. And it can test at any product level, but it cannot have more than 20,000 gallons of ullage in the tank at the time. The minimum test times are based primarily on the amount of time that it would take for water to accumulate and be detected in the tank. And we have two types of probes, the magnetostrictive, which has a little sensor down at the bottom, which again is using this common technology for level change. And it can detect an ingress in a period of 1 hour. A different type of probe we call a standard probe. It's a printed circuit board, which has a capacitance type measurement. It has slightly less precision, so it takes 2 hours to detect the minimum amount of water coming into the tank. And there are requirements that our technician must ensure are in place for that to be valid. either that's if groundwater is below the bottom of the tank and there's essentially no chance of water ingress, or if there's an existing cross-section of water, or we can measure and identify that the tank is inserted in the lowest portion of the tank. Moving on to types of line test technology, I've kind of broken these into categories that I call the constant pressure hydrostatic test and a pressure decay style test. The constant pressure test includes brands such as the TLD1, which technology uses, and this one over here called the Accurate test. They use nitrogen gas to provide amount of pressure above a column of liquid, and then the only thing it's really measuring is a change in that liquid level. The pressure never changes. It's just a volumetric change in this cylinder that represents any fuel that may be getting out of the line. A different style of test is a pressure decay test, similar or used by petrotite test methodology or the PTK88. Here's a picture from my archives from way back when of one of our technicians doing a test. Was that you, Brian, way back when your hair was different color? This method uses a hand pump to apply pressure to a pipeline, and then the amount of pressure decay as well as volume change is measured on a periodic basis, usually either every 10 minutes or 15 minutes. Steve's going to cover a little bit more about that with the petrotite test method. So they're both different ways to come up with an answer. There's kind of pros and cons to either one. I'm not going to debate that with you right now. The line test can be conducted with other technologies, such as an electronic line leak detection that may be part of an automatic tank gauge console. I'm not really going to get into those right now either. So this is the method that technology uses, the TLD1 line tester. Again, it has a listing with LG113 to kind of summarize the operating parameters. Has the certification rates, types of fuel. The minimum test time is 30 minutes. This is the official number we got from our certification, but as I'm going to show, we actually go above and beyond in a number of cases. The maximum piping volume is 172 gallons if you have steel or fiberglass pipe, and 119 gallons for flexible piping. So if you got more than that, we would have to find a way to isolate that and break it down in a smaller section of piping. It's possible to test multiple lines if they're smaller than this volume, if the entire volume doesn't add up to that amount. So our actual operating parameters, we establish, if we're doing a steel or fiberglass line, within this 30 minutes time period, the last 2 consecutive readings have to be below our threshold. And that threshold is listed down here. We're using numbers which are much lower than the 0.05 gallon per hour that was the statistical number. We found through our experience that we're able to find smaller leaks in lines, and since no leaks are really acceptable, that's what we do. The flexible piping, we have slightly different pass requirements. If it's 49 gallons based on a prior certification, we're able to pass that with 2 consecutive passing readings within a 1-hour test. If it's up to 119 gallons, we need 3 consecutive passing readings. And we use a threshold of 0.02 gallon per hour. The setup of the line test is usually conducted from the dispenser. This is not mandated. It works equally well from either end, but usually it's done in conjunction with a test of the mechanical line leak detector, which must be conducted from a dispenser. So that's usually where we'd set up our line test equipment. The jumper hose would go from the test equipment to the impact valve underneath the dispenser. A nitrogen hose, this red hose here, would come up from the technician's truck, and that's set at the test pressure. The cylinder is filled with fuel. You can see there's a fuel can here and a funnel. This top portion of the tester actually has a reservoir with some fuel that can be drained down into the test apparatus used to apply fuel to the line. Once the line is filled up with fuel and the pressure is applied, then the technician monitors the change in level, and he records that data manually just on a clipboard. Here's a close-up to see a little bit better view of what he's looking at there. This is the product reservoir on the top. Fuel can drain down through here and then come up into this sight glass cylinder, which just has a vertical scale. It's measuring the linear change on the column of liquid when pressure is applied. We use redundant pressure gauges as a means to avoid calibration. We found that with dual pressure gauges, and most likely 3 pressure gauges, we can ensure that we are conducting this test at 1.5 times operating pressure. The nitrogen supply comes through here. This is a line from the bottom of our cylinder, which would be attached to the piping system. There are many different ways to isolate the piping for a test. And most commonly is probably at an impact valve. We would attach a jumper hose here, and then we'd trip the impact valve so we're not applying pressure up into the parts of the dispenser. Those would be examined by a technician to see if there's any points of leakage, but the test pressure is possibly more than the pressure should be applied in the dispenser, so we would isolate that from the test. At the STP end of the tank, assuming most of these systems are pressure these days, it gets a little more complicated. We love to see this. If you've got a ball valve in a self-contained sump with a monitoring system, we would simply close the ball valve and run the test up against the ball valve. If that's not the case, or if the ball valve's not holding, we could screw down the functional element check valve, which could help to hold pressure in a tank. Or in some cases, we remove the leak detector and we buy a handy device from Steve's company, by the way, the Silver Bullet isolation tool, and that isolates very well. This cutaway is, if you can see it, it shows kind of one of the features of the common red jacket turbine. There's an O-ring right here that could leak, and fuel would go past there during a line test and drain back down into the underground tank. Now, that's not a leak into the environment, but it would cause a failure of a line test. So we have a different methodology. It's got a little plug that comes off the bottom of here that can isolate that O-ring. So, and there are many other tricks of the trade to make sure the line is totally isolated. If all fails, the line would have to be disconnected by taking apart the piping and breaking the unions and things like that to totally isolate it from the tank and dispensers. I've got some comparisons between kind of a typical line test and an electronic line test. I get asked this sometimes. What's the difference? Why don't I just use that electronic? And here's a way maybe to help evaluate it. The line test, again, is certified to 1/10 of a gallon per hour leak rate. The electronic line leak detection typically comes with 3 different certifications or 3 different softwares that have achieved a different certification. So you need to make sure what you've got. Some will just do a 3 gallon per hour leak test. Some will do a 0.2 or even a 0.1 gallon per hour leak test. And again, a line test, a certified technician has to go to the site to conduct the test. And we'll also examine the condition of the dispensers and the sumps and other things while at the site. The electronic line leak can run automatically from the console, or can be run manually from a person at the console or dialing in remotely. The line test is isolated from the piping, is isolated from the tank and dispenser during the test. And that helps to avoid some false alarms that may occur with some electronic line leak detection. There can be some things that would cause it to show a failure that's not really a hole in the line. It's just a valve that's not holding at one end, either check valve or a solenoid valve or something like that may not be tight. The line test involves manual data collection, at least the methods we use and most of the other methods I'm familiar with. So a technician is manually collecting data and calculating a leak rate, whereas the electronic line leak detection is an algorithm that's run by the processor and the console. So those are some of the differences just between the line test and the ELLD. And I've got a couple of references here if you need further information, and as well as I can be contacted. This is my way to avoid the search engines that run out there and like to send me spam, but that is my email address if anybody has any follow-up. And with that, I will turn it over to Steve. Thank you.
Well, good afternoon. First of all, whoa, a little too far ahead. First of all, there's 3 kinds of people in this audience today, right? Some of you are vacationers, needed to get the heck out of the office, so you're sitting in the scuba I need to pray for you. Okay, let's pray for you. Second of all, you guys are learners. Some of you in here actually want to learn something. They're hoping Mr. Purpora and Mr. Hoffman teach me something today. I also want to pray for you. And some of you are prisoners. I got to be here. I hate this. So I want you to turn to the person next to you and give them a high five, because this is the last speaker of the day. All right. A little energy in this room. This is kind of a boring subject for a lot of you. Because quite frankly, tank testing is kind of a dinosaur in California. But being honest, a lot of you, how many of you witnessed a tank test before? How about in the last year? All right, excellent. You're getting out there and doing it. I like to hear that. How many of you actually knew what you were looking at? Or you bought the sale of goods that the tester was telling you that. Oh, don't look at that. Look over here. Yeah. Well, what we want to do with some of the debunking is to discuss. I'm going to discuss a variety of different things. For those that have seen me speak before, I'm kind of an energetic guy. It's kind of tough that I got to be trapped in this little box. I like to get out in the crowd and kind of mix it up. Because really, it's about you guys. Because quite frankly, I've been doing this a long time. I already know it. It's really how do I translate that into you and bring some enthusiasm and hopefully some passion into what the heck we do out there. Because quite frankly, it's a really boring subject. You got Vita roots, we got Vita root in the off. Hey, I think the tank gauge tells me everything's good. California, you got double wall. All right, Barbara Boxer almost got it through the whole country. Okay? It's been around for a long time. But California leads the league in a lot of things. So we're going to discuss that as we get through it. You can tell I like to have fun when I'm up here. A little history of testing. I'm not sure if people really understand the birth of this. I actually was going to try to write a book. Dr. Wilcox was going to help me, kind of the real history of what tank testing has really become. The methods of tank testing that we have out there, some line testing, and then what's left for today and what's coming in the future. A little history. Air testing, as Brad mentioned, you know, compressors have been running around testing tanks for a long time. But in 1969 in Ann Arbor, Michigan, there was a unique test this one day. They decided to bring the local fire departments from 3 communities to show them how they could use compressed gas on a tank that already contained gasoline. Okay, everybody together. Compressed gas with gasoline, we got a bomb, okay? So what happened was they were actually trying to pressure to 5 psi in the tank. Well, the last thing that those guys did before they got killed was tap on the gauge. They put 25 psi in the tank. The whole pad lifted up and landed on the guys in front of the fire department. In Ann Arbor, Michigan, they passed no more compressed air on tanks that contain gasoline. We still have that today as an NFPA kind of standard. We don't talk about it, but there's still a lot of jockey contractors that are still doing that stuff. Thankfully not in California, because I think they'd be thoroughly killed in this state if that was the case. The first Kenmore test. Now, Kenmore became Petrotite. That was kind of the evolution. The history of this is in 1971, my father was working at Argonne National Labs, smashing the proton atom, kind of a scientist stuff. But on Saturdays, these guys would race GTOs, these engineers, Shell, Mobil, all these guys would get together, about 12 of them, and they go to this one gas station. If you remember, we had racing gas, yeah. That's when we had lead in the fuel, remember? Lead. Not ethanol, not MTBE, lead. All right, so racing gas was basically the white lightning stuff that the boys in Tennessee and Kentucky figured out if you stuff it in the gas tank, hey, she runs a lot better. So they were in there getting the racing gas, and this big tall Mobil guy came out with his Mobil shirt on and said, you smart engineers are in here, this is the north side of Chicago, you smart engineers are in here every week. Why don't you tell me where the hell my gas is going? My father said, what are you talking about? And he said, well, I've been kind of taking my readings, and I think I'm losing fuel. 1971, what was not on the bottom of tanks that's there today? Strike plate, all right. So you've got a little audience participation. This is going to work out all right. So, strike plates. Sure enough, my dad found some equipment called the Kenmore from Fred R. McLean in Canada. And by the way, technology and Petrotite were birthed in Canada. Let's be honest. Canadians, eh? All right. So, what happened was he brought that equipment down to Chicago, modified it a bit. He tested it, and he couldn't believe his eyes. So guess what he did like every good he retested it. Sure enough, it was leaking. They dug it up. Tank stick had punctured a hole in the bottom of the tank. Pretty common thing in the early 70s when we started going out there testing. Turned out this guy was a Mobil jobber and had 300 Mobil stations. So he leaned over to my father's ear and said, you better start a business, young man, because you're going to have to go to working for Mobil. So in 1972, we became formalized as a business and became the first in the country to run around all over testing tanks. 1978, we were here in all over California. That was when Harvey Howard was around, if you guys remember that name, H.D. Howard, Sacramento Equipment Maintenance. Today we have Tate as a partner, Fernando Verdugo down in the southern part of California. I'm very familiar with what's going on. I started when I was 8 years old with my dad. I took my first gas bath from a tanker, lifted up the hose, covered me head to toe in gasoline. I remember that stuff. I still thinking I was never going to be at a gas station, but here I am 40 years later talking about it. The truth is testing has been part of what we've been doing, but testing was birthed out of troubleshooting, not out of compliance. That's where the origination of tank testing came. Nobody really cared at the beginning, but Mobil sent us a little protocol in 1979 that said, you guys saved us almost $2 million in fuel losses in 1 year. Now, there's never been any real conclusive studies there past because they never wanted to admit they lost that much fuel. But boy, we found at least every single site had a tank or line leaking from 1971 to about 1979 across the United States. 1974, my father was quite a clever marketer. He decided to go to the Des Plaines Fire Department and said, how about I test all your tanks at the fire department? Back then, fire departments had tanks for their fire trucks. How about I test your tanks for free? Well, of course, the fire department said, sure. He knew 4 out of 10 tanks were going to fail. Guess what the Des Plaines Fire Department did in 1974? Every single tank will be tested in Des Plaines, Illinois, because they figured if the fire department had leaks, so did the oil company. Rightly so. So that's the first known regulation that I can find on the books. I've talked to people in France, all over Europe. About the mid-70s is when they started doing their testing as well. Late 1970s, Horner and Ainley was also part of the origination. 1980s, we got vacuum, we got some mass, we had tracer, all through the 80s. But in 1988, the EPA adopts testing standards. For those that are around, remember the Edison project? And that maybe bring back some memories for some of you guys. My father was one of the contributors of data. We had tons and tons of data we contributed to that. So we were part of that evolution of the rules. We understood that what was needed to be doing. So it came out of probability detection. Now it's the 95-5 rule. I don't need to put the 5 up, I think you get that. But it meant that if we tested 100 tanks that were leaking 0.1 gallons per hour, I would correctly identify that 95 out of that 100 were leaking. We'd hope it'd be a lot more, wouldn't we? Truth is, it was about 98%. So we came up with these tolerances. By the way, does anybody, 0.1, that's a Coke can. Okay, that's a soda can, roughly an hour, going into the ground on every tank and every pipe. Of course, that kind of drives me batty personally to think that we have a regulation on a piece of pipe that contains 5 gallons, 0.1, and a 50,000-gallon tank of 0.1. Somehow that doesn't kind of jive with me. Less volume should be a tighter tolerance. But that threshold of detection means that the equipment actually had to find 0.05 gallons per hour for the measuring pieces. The equipment that did the measuring were looking for 0.05 to mean equal or equivalent to the 0.1. That's true with all the test methods we have today. How did they do that testing? For those that see this, hopefully you've never been on a dialysis machine, but this is a peristaltic pump. And this is how they did it. They would actually pull out the 0.1, 0.2, or whatever was needed to prove that that equipment would find it. But the truth is with most methods of testing, including ATGs, if you have higher fuel levels, differential in pressure is going to mean you're going to have a higher leak rate if it's below the fuel line. So differential pressure became a big issue as they began to discuss it. So we wanted more pressure in there. See, the truth about tank testing is that one of the things I want to debunk, as the name that Sean gave us, the debunking, I might have come up with a clever name, a little more auspicious for us, but debunking is an interesting thing. But here's the deal. If on a tank test, the ATG is giving you missed results, raise the level or lower the level. Do something different. You can change the physics of the tank. Most places, the blind spot for most tank tests is 50% full. 50% full is kind of one of the spots that's a bit of an illusion for us. So we may have to change the level in that case. That's for troubleshooting. High water table may equalize. We've actually had situations where the water table is actually equaling the leak rate. So what do? We lowered the level, the water came in, failed the test. Those are some of the things you need to pay attention. These are the parameters of testing. Tank testing methods that were out there and kind of birthed through. Kenmore, now the Petrotite, was an overfill method. US test, which is an ultrasonic method, basically the sonar, how they found the ships back in the day. It's basically a sonar technology. Alert is mass measurement. Technology, Esterbrook, we have vacuum, and we have tracer. Tracer in California, boy, that's Randy's probably not in here, is he? For those that know, the tracer thing was quite an unusual birthing here. I think in California, don't you have to have 20 tank tests as an assistant before you become a foreman? Am I saying that right? Okay, I don't want to bring up old wounds. A couple people are laughing in here. But Tracer changed that formula a little bit. They got in trouble for it, but they changed the formula. They took the science away from the training the technicians a bit. Kenmore, look at that. You know, it's kind of interesting, and I think about it all the time. Actually, we did a testing here, a training for an LAX. We actually remember going into the actual black room where the planes are coming in. I was like 16 years old. My dad said, "Do you want to be an air traffic controller?" I went, "No, this looks really bad," because they were in a dark room smoking cigarettes. It looked kind of scary. But I remember testing here at LAX. I do remember the actual engineers from Chevron and Mobil and Texaco actually coming out to the training. We actually taught science of what testing was. Thermal coefficient of expansions. What does the tank end deflection do? What does the water table do? All that. It almost felt like we had to be scientists and engineers with all the math that we had to do. That's how we tested tanks. Some of the things. The first leak was found 1972. Mobile tests nationwide. They gave us 5,300 locations and handed us a contract. And I'm going to say this in public. They handed us $100,000 in January and said, "Tell us when you're getting low, we'll send you another check." Man, those days, I wish I had those days back. They don't do that now. It's the other way around. Please, can we have the money? Okay, so 1977, we went nationwide. The technicians were learning the science of testing. Why wasn't I able to do that? For those that remember the old Petrotite days, that actually maybe had Jim Wilkerson. He was actually one of the trainers here in the California area, or they had my father. They put science first. Physics is what brings us together in this testing. It's physics that's going to find it. They use vacuum because it's a physics principle. That's what we're testing with, physics. California's taking it to another level. They've double-walled everything, including the vents, and they have all these positive shutdowns. I love it. But the science of testing is still there. The data used by Petrotite was the first data that was really manageable because we had thousands and thousands and thousands and thousands of tests in America, and they used that to birth some of the regulations we have today. So, when Petrotite came out, the rules in 1988, you said you'd better be able to handle temperature. We handle that by circulating the liquid. The philosophy is that you have stratification in a tank. You got red marbles and blue marbles. If I circulate them together, I'll make purple marbles. That was the premise. We wanted to get the average mean temperature in the tank and then correct to 60 degrees the coefficient of expansion. Thermal dynamics of liquids were taught. You talk to technicians today, they look at you with a blank stare on their face. What is that? Okay, science. Okay, what about tank end deflection? We had two levels. We had a high level, which put 4 pounds of pressure at the bottom of the tank, no matter what the water table was. In fact, I remember being in Miami, being about 45 feet in the air on top of the canopy, for gosh sakes. So I remember those days vividly. So we had a high level and a low level to handle as the tank end would come in. Fiberglass, the ribs go. Steel, the ends go. Always remember that. Groundwater, we had to be able to handle groundwater, so we overpressurized. We always looked for the water. Water's heavier than gas. It's heavier than diesel. It's 0.036 per inch. Diesel's 0.031. Gas is approximately 0.026. So water was more heavy than those liquids. You had to know what the inward pressure was from the water. Some of the strengths and weaknesses, you could use it almost in any situation. Overfill. Technicians were trained and certified. It was a week-long class and very few people passed back in the day. In fact, they had t-shirts, "I survived the class." If a leak was there, you found it. You had to meet the tanker and carry fuel, some of the issues. It was very hard not to spill. When a leak was present, you added more to the contaminated area. Made Brownsfield's cleanup a bit bigger. This is some recent Petrotite tank test overfill data. These are the tanks that were tested. Now you can see the percentage is still pretty high, but they're still using it. There's a few places in America that are using water after construction. They put the pea gravel on and they fill the tank 100% all the way to the vent and say, let's just make sure everything's good before we pour the concrete. So I have about 4 or 5 places. My boys, Diamond Shamrock, I don't think I got anybody in here, but Texas. There's been a couple times where in Clay, they wanted an overfill test. There's a couple situations where it's needed to be done, on the coast with tidals, things like that. You had to have some situations that were adjustable to water table. The science of testing, it still hasn't left us, I believe. US test, ultrasonic. What is that? It's basically a sound wave through the liquid. They're measuring time of flight, space is what it's called, TOF, time of flight. How long does it take for the liquid to bounce off the wall, come back to the transducer, and send a signal? That's how they could tell if the temperature is getting cooler or whatever, thinner, thicker, hotter, cooler. The problem with that is it's really temperature issued, meaning if you get if the skin's exposed at all, the sun's hitting it. US test had a bit of a blind spot. We used it a lot for many years, so we were very familiar with it. If you were anywhere near a delivery, you were in a world of trouble with the temperature. Alert, that's the method that we're using today. It's a mass-based sensor. It's designed to detect changes in fuel content. If the fuel physics is changing, we're going to change with it. The actual mass sensor is going to see that change. This allows the technology not to be so slave to temperatures. Actually, believe it or not, Brad and I were in Saudi Arabia together the same week. He's training one end of the country and I'm training in the other. We still have a hard time believing wonder if they did that on purpose to bring us both in country. But that place is hot. So we saw temperature effects like nobody's business. And they had these little steel shelves over the tops of tanks. It was third world. It still is. One of the things that we're benefited by the mass sensors, we've been able to find and detect the water ingress as the phase separation or the alcohols, absorbing the water. If you took 1 gallon of E10 and 1 gallon of water, you'd get 1.8 gallons. Let me say that again, 1 gallon of water, 1 gallon E10, you get about 1.8 gallons, approximately. That's because we're using a mass-based measurement, and we can tell that. How about tracer? Chemical markers. Some of the things materials were not found in the environment. The probes are installed around the tank. Probes are sampled after predetermined. The presence of tracer outside the tank indicates a leak. I think our boys at CGRS, I think I got a couple guys here, I think they're still running some tracer stuff. When the water table is present, though, it can cause some issues. Some issues with that. This is a little picture that gives you an idea what tracer was doing. I'm kind of big into pictures. I think pictures say 1,000 words. And so these next few pictures are going to try to hopefully speak a lot to you. There's a lot of different test methods. All of them have a bit of a blind spot, to be honest. They all have something that's a little bit off. The testers know it. I'd say both technology and our equipment are probably the most rigid certified guys that run equipment. With all due respect to my competition that's out there, a lot of them are hook and go guys. Brad and I were just having that discussion. I don't know how you can test a tank for less than an hour. We find that the most ironic thing. Could you imagine going in a physical, you're not feeling well, the doctor takes a look at you and says, hey, you look good, get out of here. And that's not a physical. That's what we got for testing in this, not necessarily in California, I must say, but the rest of it. Tank testing today. Why do we do it? You need to do it for compliance. If you got a single wall test, you're using SIR. SIR, you still have SIR in California? A little. We're getting away from that, right? That's one of the things about SIR. You tax the guy by having him test the tank. We knew that from the state of Illinois. We do the same thing in Illinois. If you got SIR, you got to test the tank in the line. SIR is a human error issue, right? We have a lot of humans doing SIR. So you may have to test it for that. Water entry. Do we ever have water entry in California? You guys got phase separation anywhere? Does that happen in California? A couple hands raised, certainly your single wall guys. Troubleshooting. Troubleshooting. This is the magic of tank testing. Because quite frankly, if the tank's buried in water, you got a Veeder-Root pumping out 0.2 every month, everything looks great, you're just blessing that tank. What do you do when there's a problem? That's where tank testing is needed. Tank testing is prescriptive. We're coming in there to take a look at your tank. By the way, how long is the test good for? Anybody? How long is, if I go out and test your tank today, how long is that? You already know that answer. How long is that test good for? The minute I drive away from the location, it's over. Seriously. So don't think it's good for a year. That may be a compliance thing because you have paperwork for a year, but that test is not good for a year. Boy, both technology and ourselves have been saying this since we're blue in the face. We leave 6 months later, they say there's a problem. We find out that there was a gardener cutting into the vent pipe. All kinds of different things have happened. We cannot be responsible except for that moment in time. That's why it's great that you get out a chance to witness the tests. It's in every state law, by the way. All 50 states have, they can witness the test. Of course, they got to be notified the test is going on, and they got to test on normal hours, not 2 in the morning. Yeah, night testing. That should be banned right off the top. No more night testing. You got truck stops in California? How do we test those things? I heard more frequently, right? Is that true? Do you guys test these more frequently because of the throughputs? Did anybody answer that? A couple nodding yes. They're small cities, truck stops. When you hear somebody's in and out of there in an hour, that's not possible. You can't even open the lids up in an hour. Now, California has 3 men on most of those sites because every one is deep buried. Every one of those truck stops has got a deep bury, way deep. So it's very hard to get in. You're running the triangle, you're running the full hazmat materials. You're in there because it's not a safe environment. Truck stops are pushing fuel like there's nobody's business. Some of them do 5 million gallons a month. Do you know that their Warren Rogers, I believe, is certified for 2.2 million, I believe, some number close to that? So that means our best SIR in the country is 2.2 million, and he's doing 5 million a month. We have over 130 stations in America that do over 5 million a month in diesel. That's where tank testing's needed. We have states, unfortunately, that have gotten there and they're so big and so disastrous, they don't know how to handle them. Tank testing is still needed. It's an art in time, but it's also based on science if they're doing it properly. Let's talk about a little bit of groundwater. Everybody has an issue with groundwater today. Everybody. All of us need to know, when we had MTBE, it was awful when it went out into the water because it basically wiped out the water table. It smelled awful. Nobody wanted to drink it, right? It wasn't bad for you. It just smelled terrible. And it was here in California this is all kind of started, right? ARCO. God bless them. I really loved ARCO, a great oil company. They were always forward thinking. I don't care what you think about oil companies. I've dealt with a lot of them. ARCO I liked. They tried engineering solutions. They were proactive. They wanted testing. They wanted people doing it right. Can't say what's there today because costs have driven it. I think anybody that ever walks into an oil company, the first thing they say is, how are we going to save money on compliance? That scares us as companies that do that work. That means you're going to try to cut our corners somewhere. That's not what we have. Part of the reason major oils are leaving is because they're getting sued for bad habits. So bad habits make guys like us upset, the ones that care about the testing. Not everybody does. You've probably witnessed someone that you went, boy, I don't know if that guy really knows what he's doing or not. That's why it's important you know what's going on. You know the parameters of how they test. How does groundwater affect the test? Well, if it's an equilibrium state, you might have just enough pressure coming in to mask a leak. If it's not, you may have to, if it's that situation, you may have to raise the level of the fluid or lower the level of fluid to determine that there is a leak or not a leak. Water is an issue everywhere. It's getting into the gasoline and it's pulling issues out. See, MTBE would get out in the environment, be a problem. Now water gets in. So now we're trying to protect everything from the water coming in on ethanol-based products, which means tank tops. Tank tops, tank tops, tank tops, tank tops. Now, 40 CFR subpart CCC is not applicable to you. However, testing a stage 1 tank top is the most important test with an ethanol-based product. A lot of double wall tanks aren't 100% double wall, right? They don't cover 100% of the tank. What about the derisers? Good thing spill buckets never leak. I mean, come on. It's always on the top. The stuff that is touched by customers is the biggest issue. Stage 2 vapor recovery nozzles touched by a customer. You almost need an IQ test to pump fuel these days. You laugh, but you know what I'm talking about. They throw nozzles. Oh, this stuff never works. Crash. There's always water in the gas. Then why are you getting gas here? I don't know. I just keep buying it here. All this stuff keeps going on and on. And we regulate people that are the customers. Unfortunately, I don't know if we got any DOT. The DOT and the EPA don't play in the same sandbox. Why do we have flapper valves? Because spill buckets are meant by drivers. Hey, I can just take my full hose and pour it right in there. That's why we have spill buckets. But in the 70s, they just poured it right in the grass. I remember thinking when I was a boy going, Dad, is that right that they're just pouring that gas right into the grass? Shh, son, nobody will know. Oh, yeah, right. Now they know. We have rules because of them. We have flapper valves, overfill alarms because of the drivers. With all due respect, they're glorified cab drivers. They want to get in and out as fast as they can. Oh, you got to pop it? Sure, there's a screwdriver in there. That's not the vapor recovery hose, that's a screwdriver. And how is a person supposed to witness a delivery? Tons of oil companies have tried to put all these checks and balances. The guy comes in at 1 in the morning. They got 6 drunks buying cigarettes. They're not going to get from behind the counter to witness the delivery. I was at a site one time, and the delivery alarm's going off. And I said, oh, you must have an overfill. And they go, no, that's how we know we're getting a delivery. But that's what we have today. So now in California, we got A, B, and C operator training. Has it improved the compliance in this state? Would you say overall? You're not perfect. A couple nodding, yes. Well, it's hopefully putting some awareness to what's going on there. This stuff still needs to be tested. Do you know why? Because we have humans putting it in. When enhanced leak detection, is my boys from CGRS in here? When we had enhanced leak detection came rolling in. Now, I was here when Shala, God bless Shala, pushed it through. I mean, literally pushed it through. Because there was only a German solution at the time, for those that remember. How many of you guys remember that? There was only a German solution at the time. That made everybody quite upset. What do you mean we got to go buy it from a European distributor? Well, OPW and everybody else ran like crazy to get that situation solved, okay? Enhanced leak detection. What was the fail rate? Anybody in here remember what the fail rate is the first couple of years? It was huge, right? In installation. These guys were failing helium tests all the time. It took them weeks sometimes to get it right. Guess what? The contractors got better. Contractors got better. You guys have some of the best contractors because they're put through the tooth and comb, real tight. The rest of us are going, oh gosh, I wish we could get some of that. But that's the truth, because you guys said this is where it starts. It starts at installation. Properly installed system with double wall fiberglass and right should be 100 years, man. Should last a long, long time, beyond that. We have tons and tons of experience with fiberglass. Tons of it. So it's important that you guys keep doing what you're doing. You know, it's interesting that we don't have a lot of testing in California. That's because they painfully went through this process. And I heard all kinds of horror stories from the contractors. Oh my God, I'm here for a week and I got these helium leaks on the top. It's killing me. And it was costing thousands, like $10,000, $20,000. Am I speaking right? $10,000, $20,000 for these guys to come do this testing. It was amazing what you guys learned. Troubleshooting. What does that mean? My Vita root's periodically showing me a fail or something's happened periodically. That's when you need tank testing. That's when you need somebody that knows the science of tank testing, that knows how to troubleshoot. Let me ask you, if you think you have a little bit of a release or a leak problem, and Brad and I went out to do the test, and Brad sucked on one end of the vent, and I sucked on the other end of the tank, and we found the leak, would you ask us, was that certified? You'd say, thanks for finding the leak. Troubleshooting doesn't mean anything to do with compliance. Zero. Find my problem. Tank testing has to change when they go to troubleshooting. Both our companies try to put the best guys forward to troubleshoot. All of our companies do. When you're finally in that need of a heart surgeon, you're going to go, I want the intern. I'm not in that line. I'm in the line with the experienced person. That's why when it's troubleshooting, you want an experienced tech. You want somebody that knows what they're doing, that understands the science of tank testing. It's becoming a lost art, quite frankly. It's important that we have it. We still need people to do the science of what's going on. I remember training the oil engineers when I was 16, and they're 28 and 29, and these guys are totally brainiacs, and I was able to explain to them what we were doing, because it was still science. It doesn't change. Post-construction. You guys have the best post-construction testing on the planet. Amen. God bless. Florida's adopted, I believe. Am I right? Florida's kind of moved into that. Maryland has kind of moved into that as well. I wish the rest of the states would adopt that. It drives everybody scary crazy when they saw the fail rates you guys had and the costs for the sites. See, part of your program works because you can find them. With all due respect, you can find them. Programs that have that next level have teeth. Your program works because you have teeth. And you're not afraid to use them in California. You guys will snap a fine on people that are bad operators. God bless you. Because there are people that are cutting corners. I don't know if you know this or not, but your standards have been used in other court cases. They've actually held oil companies that operate in California. They go test in Connecticut, and they operate them properly. They say, you knew in California to operate that way, and you didn't do it right. We're busting you on that. So they're using what you've learned to bring it across. Equipment limitations. You got to know what the limitations are. I'm a big fan of obviously you heard my little rant about truck stops, a small one. I've done a few national presentations on these things. Truck stops need to be tested regularly. How many meter calibrators in here? What if I put 5 million gallons, let's say about 800,000 gallons through 1 meter, how many months will it take before I start losing calibration on that meter? 2 months. We're using SIR. Just saying. These things are notorious. We've had leaks of 800,000 gallons on a truck stop in Montana. Georgia has 2 acres of diesel wetlands. We're trying to find the actual animals that'll go into the diesel and hang out, but so far no good. And most truck stops are not next to houses, so the people don't complain. They're out in the middle of nowhere. They're big cities. They got power. They got money because the tax money comes in. When they build a gas station, they say, we're hoping to sell 1 million. They're going, they hope to sell 10 million a month. But they're not going to tell you that when they permit. On to line testing. This is the most important test that's done, by far. By far. Tanks are giving us signals that there's a problem. We got ATGs in there. We got water ingress. We got double-walled brine. We got double wall with vacuum sensors. We have things that are monitoring the tank. The pipe is the issue. More leaks today are still found in the pipes than they are in the tanks, by far. Petrotite line test method, again, was originally Kenmore. It's been used since 1978. Tested over 5 million lines worldwide. Uses hydrostatic pressure. I remember my father explaining to me how they tested suction lines in the early 70s. They would take for those that know this, I'm sorry for the ones that don't, they take the air eliminator copper tube off and they put a balloon, third-party certified balloon at that, onto the top, and they turn the pump on. And if the balloon inflated, they were sucking air in, therefore there was a leak. Hey, that's pretty good. It worked originally. I mean, that was obviously nothing third-party certified. But you know what? When there's a problem and the guy's spitting air and he's getting water into his cement trucks, he doesn't care how you find his problem. Find it. Again, back to troubleshooting. Some of our keys. We would measure the air pockets. Our system calibrates every single line. I have a fingerprint of every single line we've ever tested. I can tell you what the resiliency is. I can tell you what kind of air pocket, what kind of sensitivity I have. Because every installer from the 60s on always made 1/8 inch back. No, they do this sometimes. So we'd have entrapped air pockets. That messes up mechanical and electronic leak detectors, by the way. You know, it's not part of the requirements, but we're going to start paying attention to that because electronic leak detectors, you know, FE Petro, are they in the audience with us today? If you put a red jacket leak detector in FE Petro pump, you're pulling air into that line every time. We recreate a leak to verify. One of the things we train in the Petrotite class is that we want to sweat a plug, we call it. We actually loosen the plug while we have an inspector or somebody on site to create a leak, a small leak, so that our equipment would have found it. We are trying to calibrate every time we test to show we could find a leak. If you're at a site and everybody goes, yeah, it's great, here's the coffee, get off the site, because that's what they want you to do is get off the site, okay? Ask them, could you show me what a leak looks like? Crack a hole on the ullage. Do it. See, that's testing. You can test chemicals with this. We do an interface. We test a lot of naphthanes, a lot of nasty stuff. We have a lot of industry in the Wisconsin and Chicagoland area. We do a lot of chemical tests. Excuse me. You can test big lines. You know, I've had this conversation a lot of times. My dad got an ANSI military protocol. We tested 3-mile long, 8-inch diameter pipe. Now, there is no third-party certification yet for that. Now, we can go to KCI Airport and do it. We've been doing this since the early 80s, testing large pipelines. The biggest one I personally tested was 2.5 miles long, 12-inch diameter. And we created a leak, and we sure enough would have found it. Now, we go all the way to the 0.1 or up to 3 gallons sometimes to show that's the number we need. But each time we test with our equipment, we know what kind of leak we can find because we generate a leak. We calibrate each time. Data trends. You know, SIR is about trend analysis, right? SIR is trend analysis, basically, mathematical trend analysis. The more data points, the better it is. Data trends tell us everything. You show me data. I actually have some inspectors that have sent me petrotite tank test data, for gosh sakes, from the early 90s. And they've sent me line test data. I can look at the data and see the trend and tell you what's going on. Trends are everything. 3 data points is a beginning of a trend. I need to see trends. Trend analysis. The technician training and retraining, we were very vigorous on our training. We still are, have a very, very active 2-year training program. I'd say both us and technology are probably the most serious about training their technicians. There is no greater thing than actually having a technician know what he's doing and be able to explain it to an inspector. How does a leak detector, that's very difficult for an inspector to believe he knows what he's doing if he can't answer to you what he's doing. But now the knowledge is passed on. One of the things that's unique about petrotite, there's over 200 state inspectors certified on petrotite line test equipment today. 200. I have some EPA officials that are actually certified on petrotite equipment. Why? I want them to witness the test. I want them to see what's going on. I want them to understand what testing's all about. It doesn't matter when everything's in compliant, but when Channel 6 shows up and you got fuel rolling down the sewer, you better be able to know what's going on and what's right and wrong. Because you're going to be asked to come out to that site and find out what's happening. I believed many, many times it's how we cooperate with the regulatory community. That has not made me a favorite son of all the oil companies, quite frankly. But you guys are in this for life. Gas station owners change hands pretty frequently these days. So I test for life isn't always made me popular with everybody, but that's how we do it. Not always the right way, but it is the way for me to put my head on the pillow and know that I've done it. Small leaks can be found, 0.008 gallons an hour. That's less than a shot glass in an hour. We're talking sweat flex connectors, just drippy leaks. You don't get a little bit pregnant. It's either leaking or it's not. One of the questions I'm asked tons of times, Steve, how come you have a number of 0.007 and you say the line is tight? Or it's under the 0.1 and you say the tank is tight? The answer is relatively simple. The reason we have a number is so that the test technician doesn't have to wait for a perfect 0. He's looking for a non-leak diminishing trend. If I lost a gallon in the first hour, half a gallon, a third a gallon, an eighth a gallon, a leak's going to repeat itself over and over and over and over. How would it get better? It wouldn't. They don't fix themselves. Not yet. We're working on that. We are, believe it or not. We're actually looking at materials that actually repair themselves, go inside the tank and repair themselves, believe it. But the truth is, those things, that's by data. If these guys have roughly the same drop in pressure and volume, we got a problem. Then what we teach is to change something in that parameter. Either increase the pressure, do something to change the physics. Because if you change the pressure on a line test and the volume doesn't change with it, it's temperature. It's temperature. If I'm losing a gallon an hour at 50 psi and I take it to 100 psi, obviously the shear valves are closed, I take it to 100 psi, I should increase my leak rate to 2 gallons an hour, shouldn't I? Right? Double the pressure that's physics. If it doesn't, then there's temperature going on. You're losing volume due to temperature change. Those things have been the premise since the 70s. The carburetor. How many changes have we seen to the carburetor? Not much. Good things work. Mechanical leak detectors, all 3 of them are made the same way. They all have metering pins, bypass, all of them, because they work. They're basically pressure-sensitive flow restrictors, but they work. So when you go to witness a test, ask the person to recreate a leak. If he tells you everything's fine, because that's what they want you to believe, right or wrong, they're going to say everything's good. How's your wife? How's your kids? You know, they're going to try to keep you occupied mentally, not on the test. Tell them you want to see a leak. I want to see what a leak looks like. That's how you witness a test. Don't tell me everything's flying and fluffy and all beautiful. I need to see what a problem looks like. So should you. Now, I like to use this occasionally because, as you can tell, I don't pull a lot of punches. So let's talk about some of the truths. Stuff still leaks. Oh no, Steve, everything's fine. That's a flex connector. They still leak. They are the shock absorbers of the system. When you see that guy getting $1.85 in Compton, hang on to the flex connector and you're going to feel that thing just shaking every time he hits the handle off. It's like a shock. Water hammer or a hammer effect on that line. And if that thing has got over a 40-degree angle, that's what it's not supposed to be over. Now you're starting to bend it. If you can see this one right here that I'm putting on the laser, do you see that crimp right there? I don't know if it's it's very hard to see. It's right past the fitting, right where my laser is, right there. That's a crimp. That is the beginning of a deterioration of that flex connector. That is the beginning of the end of that flex connector. These flex connectors, I don't know if you know this, had 10 different grades, like meat. Grade A all the way grade yuck, right? And so what happens is a lot of not good contractors would get the contract and go, wait a minute, the spec was grade A, but who's going to go out and actually check the flex connector to see if I put grade D? And that happened all over America. Now, is this a flex connector or a pretzel? These were taken last year, so they're not that old. This is still going on. They are meant to assist, not to do that. That one's around the pipe. Isn't that the most that one is actually in New York. A little kick to the East Coast, right? The other one's in Pennsylvania. Now, this kind of picture is what flexible piping would use as their marketing pictures. You don't want anybody repairing your pipe, flex piping, you just replace it, it's really simple. Yeah. This is really simple. That first pipe on the left, I can say it, TCI stands for totally crappy install, because it doesn't matter what you do, that thing's got a life of its own. It grows. You put fuel in that sub pit, it grows. Now, it's kind of funny but sad. Flexible piping originally, when TCI came out, the Society of Plastic Engineers sent them a letter and said, do not use that compound. We tried it because we make gasoline tanks out of EVOH in your cars. They're plastic tanks. And they said, that's why we use Miller Lite bottles. You know what the response was? We don't have a patent on that. They went ahead knowing this stuff wasn't going to be good. So it's not compatible with the fuels. Flex piping has grown up. The more modern era, it actually is more semi-rigid than flexible, the stuff that we have today. But if we did it right in America, we wouldn't have UPP from the UK, and we wouldn't have NUPI from Italy coming in and ransacking us because we were a little bit greedy at the table, quite frankly. I'm a big fan of double wall fiberglass. Tanks and pipes are still leaking. Where are they leaking? They're leaking at the ends, the bookends. Usually the pipe itself, the pipe's fine, it's the elbow, it's the unions, it's the turns, that stuff, the swivels, all that stuff is where we're having the problems. The vents, the ends. That rusty vent, that picture was taken last week. The owner said, I didn't realize I needed cathodic protection on steel. Now, we don't have a lot of cathodic protection in California. I'm well aware of that. Very few, quite in fact. So that science is a bit difficult in California. But the rest of the world is filled with cathodic protection issues. I don't know if you know, but a lot of caskets have anodes in the bottom of them. Nobody's testing those. But. Now, this is not the proper use of how to handle the leak detector that doesn't have a place for the copper tube. The ironic thing about this picture was the owner actually had the chutzpah to say, I empty the bottle once a week. Now, if you see to the right there, he's got an actual old DLD, diaphragm leak detector. By the way, God bless those. Because you didn't need to drill in to tap into the riser like you do on some of these old pumps. But now we don't have any non-vented leak detectors. Compatibility. Putting in the right thing at the right place. Now, this is Midwestern containment. It's called dirt. So you guys don't have that here. You guys have a lot of formal containment, which, of course, we've been trying to get everybody from the dark ages into the light ages, of course. It takes big leaks. California's had some big leaks over its history. Part of the reason you have what you have is because you guys got sick of the leaks. It's amazing to me that California has managed to do it. God bless you, many, many times over. Because you have more major oil stations in this state than anywhere else. Now, I don't know if this is true, but a couple years ago, please tell me if I'm wrong, you guys are California is pretty close to the other 49 states in pumping fuel. Is that still true? The throughput in California is almost equal to roughly the whole United States. That wasn't too far long ago, so if somebody could look that up, a couple nods, yes. I know that's true in a lot of ways if you add the diesel from truck stops in California. California is progressive, right? We're going to have what, the CNG superhighway? That's a slow nod I see coming up. People are not sure of that. But you're thinking in a different way. When you put enhanced leak detection on stuff and you started shutting down for a vent pipe leak, man, that was really monumental for us. It's monumental for the rest of the world. I've been blessed enough to actually, when I was in Saudi Arabia, be given the Allah rules of environment. They were definitely weird to read, be honest, but at least they had something. So they said, Steve, where should we go? And I said, a blend of California with a blend of the rest of us, with all due respect. Because if you started in the 50s and put it all now on from your California rule now, add that into the 50s of what you had in equipment, it would be just a disaster. Most countries have a lot of stuff that America had, but it has nothing to do with leak detection or compliance or any of that stuff. They put it in and forget about it. That was the origination of a lot of leak detection. The Vita root was first used as a glorified tank stick. With all due respect, it was just an auto stick to tell you where your levels were. Leak detection came later. California has pushed through so many different things. You guys were the first to make sure electronic leak detectors were tested because they didn't believe in the self-test. God bless you. I'm with you. I remember it wasn't, I think it was Alan Bates, I asked about this question. How's California doing in Vita-root parts? Oh my God, we're selling a ton of them. That's because we're testing. You see, if we test, we find things. If you're sick, you go to a doctor. Does he do a test on you? Look, you want the right equipment in the right situation. When it comes to tank testing, find out what the physics are around the tank. If it's clay and water, you may have to use a different method. We have some stuff along the San Francisco coast I've been partnered to testing, and they said, Steve, when the tide goes out, we see this result. When the tide comes in, we see this result. They said, obviously, we need to test in those circumstances to find out what we're seeing. Why is that changing? Because obviously the physics are changing. If you have an owner and operator with an ATG that's giving him erratic readings, have him change his level for the test. And I have Vita-root in the audience. I know for a fact they can find very small leaks if they extended the test time on a tank. Okay? If it's a problem tank, extend the test time. Do more of a precision tank test. The Vita-root will find it if it's liquid portion. I'm not a Vita-root salesman, okay? But I know that the equipment used right will do its job. You guys are the first state to actually pay attention to every piece of certification equipment that was around. I remember having coffee with Scott Bacon, I don't know if he's in the audience, discussing that kind of stuff. Awesome. Shala moved much quicker than I was used to. I never saw anybody push something through so fast, but it worked. It was painful. But California came through with shining colors. We have your data. We use it to scare everybody, quite frankly. It's true. The whole industry is a bit scared of that. The newest document that PEI, that I was fortunate enough to be part of, RP 1200, is the most aggressive, thorough document on testing ever written. Everybody should read that document. Everybody should have their hands on that document. Yes, just because I'm proud of being on it. Yeah, that's part of it. But guys like Technology and us and even Cromco and Tate sat down together and came up with the right process. We didn't make it equipment prescriptive, we made it test prescriptive. Everybody can use it. It's meant for the regulatory community so that they understand if somebody says I got to do this test, this is how it's done. We even did forms. We took Technology, some of Cromco, and we modernized these forms and make them generic so they could be used by all states, all people. The resources you have at your hands Because of what you've learned and because of where we're going in the future, you guys are a jump ahead of everybody else. And now Brad and I had a conversation a little bit before we started. We were kind of laughing, like, we're talking about tank testing in a state that doesn't tank test. It's like, let's talk about the buggy whip or horse carriage, you know. You guys probably don't want to talk about the 49ers. So, yeah, exactly. Turn the lights out. Look, it is very important that you actually witness the test, ask some proper questions. What's the water table? What are we looking for today? What's the chemical background? Do we got sand? Do we got pea gravel? Do we got clay? Ask questions of the tester. I implore you to do it. It only makes them better. Now, with all due respect, I was an ex-tester. Most testers suck at taking tests. So they're not the best at explaining it. But they can tell you what they're doing, and they should be able to mimic a leak somewhere in the process, particularly ullage and particularly line testing. They should be able to create that leak for you so that you see it firsthand. There's nothing better than a test technician saying, yeah, I've always heard it's fine. Show me something wrong. Show me something wrong. It's not passing tests that make a difference in this country. It's finding the problem. Testing was birthed out of problem solving. Tell me where my gas is going was with a catalyst to get my father involved. Right? Why am I seeing this problem? Why was the flex piping growing? We had to tear it apart to find out the chemical compound was improper. But testing did that. In America, we've got a couple different people. We got people that really care, do it right, and then we got people that want to be as fast and as cheap as they can. We have to have a balance between the two. You can have excellent work, cheap work, fast work. You can have two of those three. You can't have all three. You just can't. Testing is not a dying art. It's meant for the people that aren't faint of heart. You must be able to solve the problem. You must not just bring your piece of equipment, it only works this way. If technology or if my company or Tate gets in there, we're going to interrogate that thing till we find it. Compliance and certification doesn't mean a hill of beans when it comes to finding a problem. When you get out to a site because the owner's got fuel or somebody's complaining, who cares about compliance? Find the problem. You're going to look at last year's compliance testing, oh, what is this? It's junk, okay? He's got a problem, let's find it. Implore the equipment and the tester that can find those problems. Thank you for your time today. Any questions? Now that I've filled the room with a little bit of energy, you guys can go out and have a beer. I think we have some beers here in a minute.